Greetings, children. Welcome back. Today, we're skipping to 7.8 and we're talking about graphing systems of inequalities. So, instead of systems of equations, we're going to be looking at systems of inequalities. And since it's an inequality, just like with a normal inequality, there's always going to be more than one answer. So there's going to be a range of values. So when we graph these, we'll always shade part of the graph. So let's take a look. We're just going to take a look at the example that's on page 318. So it says, solve this system of inequalities. And it gives us the system 3x plus y is greater than 4, and x minus y is less than or equal to 8. Now, in order to graph these, we're going to put them in slope-intercept form. So slope-intercept form is when you take an equation, a line, and solve it for y. So here we're going to take the top equation first. Usually we label these a and b. So equation a here we're going to have as 3x plus y is greater than 4. So to solve this inequality for y, we're going to subtract 3x from both sides. So y is greater than negative 3x plus 4. Now remember, there's two important parts here. We have our slope and our intercept. So the y-intercept is going to be 0, 4. That's the first point that we'll graph. So when we're graphing these, 0, 4 is our first point. And then we have our slope. And our slope here is negative 3. We always write slope as a fraction, so we're going to write it as negative 3 over 1. Then there's another important thing to look at here, and it's just we have just a greater than sign. So if you don't have the or equal to part, then that means we're going to be graphing a dashed line. So we know a lot about this graph now. Now let's go ahead and work on equation B. We had x minus y is less than or equal to 8. So to solve it, we're going to subtract x from both sides. So we get y, negative y is less than or equal to negative x plus 8. And then we want y, not negative y, so we're going to divide everything by negative 1. Now when we do that, we get y, we get x, we get minus 8. Now, we have a special rule that's just for solving inequalities, and that is whenever you have an inequality and you divide or multiply by a negative number, the direction of the inequality flips. So where we had less than or equal to, now it's greater than or equal to. So we have y is greater than or equal to x minus 8. Now let's get the same information. The y-intercept is going to be 0, negative 8. The slope, since there's no coefficient here, it's understood to be 1. So we write it as 1 over 1. And then since it is equal to, it's going to be a solid line. And now we have enough information to graph these. So let's go ahead and do that. So here's our graph. We're going to graph equation A first. We said our intercept is 0, 4. So we'll start up here at 0, 4. Our slope is negative 3, 1. So that means we go down 3 and to the right 1. And then we could do that again. So down 3 to the right 1. And then that is going to be a dashed line. So we draw a dashed line through those points. The next one, our y-intercept is 0, 8. So here's 2, 3, 4, 5, 6, 7, 8. So we start at 0, negative 8, and our slope is 1. So we go up 1 over 1, up 1 over 1, and then we're going to draw a solid line through those points. Now, we've graphed linear inequalities before, and you know that you shade part of the graph. So for each of these lines, we would shade either this half or this half for the dashed line, or we would shade either this half or this half for the solid line. But since it's a system of inequalities, we want to see where both of them are true at the same time. Remember, we're shading the parts that make these lines, this inequality, true. So if you look at this one, once it's solved, it's greater than, which would mean that it would be everything above the dashed line. So it could be this whole area over here. But we want it also to be true for the solid line. So that means we're going to have to shade above as well because it's greater than. So we're going to shade above the solid line as well. So we need to figure out which part of the graph do we shade if it's going to be above both. So one way I like to do it is draw a little star because it's going to be split into 4 parts. So draw a star in the part that makes each one true. So here we're going to have this quadrant here could be true for the dashed line, and then this quadrant down here could be true for the dashed line. And then for the solid line it could be this one or this one. Now you shade the part that has both stars, that has 2 stars in it. Okay, so the part that's true is everything up here. Remember, these lines continue on forever, so they keep going. So this area keeps going as well. But the parts with 1 star don't get shaded. It would have been shaded if it was just the solid line here. It would have been shaded if it was just the dashed line over here. But since it's not, we want it where both parts are true. Okay, there's another way to figure this out, and it's to try a test point. And of course, the test point has to be true for both. So an easy point to check is the origin. Right, so let's see if the origin 0, 0 works. So here, if you try it in the top equation, equation A, you have 0 plus 0 is greater than 4. 0 is greater than 4. That's false. Even though 0 minus 0 is less than 8. That's true. Okay, that's why it's true for one of them, but not the other. So for it to be a solution, it would have to be true for both. So let's find a point that we know is in this area. Okay, so let's go ahead and just use the point 0, 4 was here, so let's use 0, 5. It should be true for both. So let's go ahead and try that. We have 3 times 0 plus 5 is greater than 4. 3 times 0 is 0, 0 plus 5. So 5 is greater than 4. Check. That is true. And then 0 minus 5 is less than or equal to 8. Well, 0 minus 5 is negative 5. So negative 5 is less than or equal to 8. Also true. So you can see this is the correct region that we shaded. If you tried this one over here, it would be true for the top one, equation A, but not equation B. And if you tried a point that was in this section, it wouldn't be true for either one. So there's a section in your homework where you're given a test point, and I want you to tell, is this test point in the correct region? So you try it in both equations, and if it is, if it's true for both, then it is in the correct region. So it's part of the solution. Our solution is all the points in this shaded region. All of them. Okay, so instead of just having a single point, it has an infinite number of points that are in a specific region of the graph. Okay, now there's also some different types of graphs. You can look at example 2. It uses 3 inequalities. So you would do the same thing, except you would graph a third one, and then you would see where all 3 of them are true. So it's not that much more difficult. You're going to get to try one of those in your homework, and it should be pretty fun. So remember, if you have any questions or difficulties, feel free to contact me. I'll reply as quickly as I can. Thanks, and have a great day.